Siri? So close. Good question. Yeah, let's review. Let's figure out what's going on.
No, I forgot. We need it. How much time?
All right, good afternoon. Thank you. So so today we're finishing up the unit, which means next time we have a review. On Friday we have a review. Then Tuesday we have the party,
Ah,
the unit party.
7-question homework.
Yeah, I'm sorry.
Oh, man, this one
It's
is
small.
Oh, this is gonna be a good day.
So I had a question about the retakes.
hard question.
Are any of you still thinking about doing a retake for first semester quiz, test? Excuse me. Okay, if you think about it, what's that?
When's the deadline?
This month, so end of the month. I think I originally said middle of the month, but I was allowed for any time in February, excuse me. So just arrange with it be this week when you want to take it. It's up to you when you want to take it. Like the normal retests are you have 3 slots or 4 slots. This time it's just when you can take it, take it. So let me know which one you want to take and when, and let's get that out of the way. Hey, let's finish this up. I gotta close the door though. Okay, so we're gonna bring together a bunch of things, our transformations as well as inverse functions. Can you visualize what this function looks like? F of x equals x squared minus 2. As you know, if it's x squared, it looks like this, and that minus 2 is going to bring that parabola to the down, because that minus 2 is outside. So we have, but is it the full parabola? There's a little bit of something after the function. Notice it says if x is greater than or equal to 0, which means we're only going to take the right side, on the right. So we'll have this, and I'll just do my 1, 3, 5 pattern from here. 3, then.
Is it always gonna be with 0, or can we kind of like the last unit do something with like a dotted line to like know that everything on whichever side of the
Good questions. There is no always, but often. But I do recommend analyzing whatever the particular problem says. I'm going to do this again so I hit all these points. Okay, good enough. I'll give you a moment to discuss how you're going to graph this guy in the same graph. You could use a different color or maybe a pen instead of a pencil, or I will be calling on someone, but how do we graph that? I was asking us to graph 2 things. I've already graphed F. Did you finish? Calling someone in just a few seconds. Where are we going today? Nice, full house. Okay, so Gideon, can you help me graph this 3-7? And how do you even say that thing in the circle that I circled up there? F negative one, is that right? Are we good with that? F negative one? See what you're saying? Let's graph it first, then let's talk about how to say it. You graph that other graph. Oh. Okay, well, perhaps it would help to know what this even says, because if you don't know what it says, how are you gonna do it? Who can help us out? What does that even say? Because we see that negative one, but yeah.
Inverse of f of x.
Inverse of f of x.
No, my point is that you don't need to be. Shh.
Inverse of f of x, or you could say f inverse. But please do not say the words in your head, -1 or to the -1. It's just clunky notation. It's really weird. Well, Gideon, do you remember what inverse functions are? It's opposite. So we take the x's and y's and then kind of replace them with each other. So if we have a graph of the function, how are we going to get the graph of its inverse? Remember? Yeah, so like the 0, -0, -2 becomes -2, -0. -2, 0. Are we good with that? I'm gonna do a different color because I can. You don't have to. Can you tell me some other coordinates?
Yeah, so one of the points is, one common name,
Mhm.
so the
Nice. Okay.
point is 3, 7, so it'd be 7.3.
So 3. Any questions? Is there another one? Another point? 2, 2 becomes. Thank you for reversing them. Nicely done. Gideon, thank you for your help. I like how you just emailed it after we got past the bumps there.
What's the math in this?
The math? So far, we've done no math except just switch.
Yeah, but what would it be?
Good question. Thank you for asking. Get this going here. Right, in a math class, it's probably important to know the answer to this question. What's the math behind what just happened? And do you recognize what function this is? It's one of the specifically. It's the square root of x, isn't it? Square root of. We'll just check with your neighbor. What is that? Square root of x? It's not just square root of x, it's been moved.
Okay, if that's good for you.
I want to know your thoughts. Dan, do you know what the function is? The red one? Any idea? As we started with the square root of x. But it's been moved a little bit. Yeah, let's see if some other people have ideas. Raquel, do you have an idea? What is that red function? Just looking at it.
That red function,
What's that?
I'm confused what you're asking specifically about.
Okay. I just want to see if anyone knows. Mia Rose, you have any idea what that red function is?
Is it x plus?
Square root of x plus 2, like this? Does that seem appropriate?
Yeah, like that. Yeah, good answer.
Dan, Raquel, looking back, do you think like, oh, so that's what he's talking about? Is because it's been moved to the left. So we have an inside transformation. Of course, that's not how we do this, but that's kind of like
That
You
is,
can think that's got
that
that.
is,
What's that?
that is.
It is. How did you think about it?
Just, I was thinking about, like, we made our original function, then, the diagonal, like, I'm just imagining a diagonal. And then just kind of flipped it.
Oh. Nice.
Like, that's just how I, like, I didn't really think about it beyond.
Yeah. So graphically, you thought about it, so the shape. Okay, so perfect. So that's half of it, of course, and that's very, very good.
What would be required to write anything down.
Well, when it says to find the inverse, you can deal without the talking right now. When it says to find the inverse, we actually have to find what that function is. Who was talking? So we do have to find that, and it shouldn't just be graphically. It's a good way to do it, but as an algebra student, we need to do this algebraically. So remember, the first step is to rewrite the function, replacing that f of x with a y. Then we take the x and y and switch them. So it becomes x equals y squared minus 2. And then there this gets exactly what you were asking before. Next step is to do what? Solve, move 2 to the other side so we can solve for y, exactly. So it becomes x plus 2 equals y squared. And last step, solving for y, we get square root of x plus 2 equals y. I'm going to reverse that because that's a little bit strange. That one. And I'm going to acknowledge that it's no longer y, but it is. How do you say this?
Inverse.
Inverse of x. So that's algebraically how to do it. And it should match what we did. So it's a nice connection that they do. Yeah?
Yeah.
Any questions? Try example 2. Oh, is this the same thing? Yeah. Discuss with the neighbor. You got it? Should we find the inverse first or graph first?
Graph it.
First, would you please show them what the graph looks like of f of x? If you know what it looks like, raise your right hand. Or raise your left hand, isn't it? Raise your left hand. I think it's just that half, isn't it? Do you see what I'm doing with the 1, 3, 5 pattern? Are we good with that? So in this case, it is the left side because it says that x is less than or equal to 0.
Yeah. $0.
So did you already have the inverse? Let's see what the inverse looks like. Yeah, it should be saying something like this. Like before it was above, wasn't it? Now it's below. Okay. And I'll do this in red because I think it gets a little bit crazy looking. So 0, -2 becomes -2, 0. Nice, I got my 1, 3, 5 pattern here. Is that a match? I hope so. And I'm going to dot in the line y equals x to illustrate. Y equals x squared. Are we gonna get the same inverse?
Yeah.
Almost. You just have to remember that when you have something like x squared equals 9, don't forget that the answer is actually x equals plus or minus 3, isn't it? So last time I was a little bit lazy and just took the positive. This time when I take the square root, it's going to be the negative x plus 2. Let's just check if this makes sense. If I plug in a 7, you see what I get? Does it fit? You plug in a 7, you get that negative 3. Plug in a 2, you get negative 2. You only get negative numbers. Yes, Ben.
But on a test, are you not just gonna wanna see that we can graph the regular and just know the inverse is the flip, or do you want us to write out the equation on or the map on the left?
I want you to be able to do everything and access what you need to do for the appropriate question. But also, I want you to just kind of analyze your toolbox and see what's most efficient and answer the question perfectly.
I have a question.
Yes, sir.
Why is it minus 6 then?
Yeah.
I feel like it's kind of out of nowhere.
Right, you're right, it is kind of out of nowhere. And it comes down to this problem. That a full answer for this, x squared equals 9. Do we agree that that would be either plus or minus 3 for something like this? Yes. So I was a little bit lazy back here when I took the square root and just took the positive. But I was also lucky because all these y values are positive. And y is just equal to positive square root.
Yeah.
In this case, all our y values, as we see on the graph, are negative. So it's kind of like something to watch out for. Anytime you take a square root from the inverse functions, make sure you're either choosing the correct positive or negative. Check, did that answer your question? Here we go. Example 3. I give you one to do it. Graphing the function and its inverse and finding its inverse. Some good stuff here.
I got.
So, one is.
So how'd it go?
I'm getting a Wednesday.
You want it to be in, yeah. Well, you want it. Student law. This year came out. So it's the most. What can you draw your?
No.
Okay, so
Draw your line you want.
Yes.
Just don't do that.
can I get some help just drawing the parent function? Just the parent function. Upton, can you help me with that, please?
Yeah.
Thank you. What-
0, 0.
Thank you.
-1,
-1 what?
-1.
Okay, thank you.
Or did I already say 1, 1?
Oh, I didn't hear it. Did you say 1, 1?
Yeah,
Okay. I was waiting for 1, 1 and it didn't enter my ear. Okay.
and then 2, 7.
2 comma, is it 7? Because the parent function is y equals x cubed. So when you plug in a 2, you get
8.
8. So 2, 8.
It'd be the opposite, so -2, -8.
Thank you. This is perfect. Thank you, Upton. So, for the parabolas, it's the 1, 3, 5 pattern. For the cubics, there's no specific pattern. You just take those 5 points and then move them around as you need to. So I need you to think 2 comma 8, -2 comma -8, and then go from there. Would you please show me which directions they're all going to go? It's all going to go 1 to the right. So, did anyone just do these 5 points, 1 to the right, right off the bat? Nothing wrong with that. Okay. Yeah, I'll erase all those. Then to the right is right there. Did I do that correctly?
Yeah.
I think I did. Okay, so there's a function. I need some help though. Now what? Diane, you're up again. What do I do now? How do I find the inverse? So I'll start off with x equals y minus 1 cubed. Do you mind if I start off there? Okay. Equals what? Okay. Well, that's how we started off. That's our basic function. And then I already switched to x and y. Exactly. So we have cube root of x equals y minus 1. And then what? Good. So we get cube root of x plus 1. And that is our inverse function. Thank you, Diane. Are we good with this? So that is our function. We could already graph that just by taking the coordinates that we already have and flipping them. It's actually really pleasant to get an inverse function once you have the graph, in my opinion. So I think 1, 1, 0 becomes 0, 1, 2, 1 becomes 1, 2, 0, -1 becomes -1, 0, 3, 8, 8, 3. And then it was -1, -8, -8. Did I make a blunder here, or is this okay? There we go. And this should look perfect if you draw the line. Y equals x through it. It's not a requisite unless it says draw the line. Or the X is a symmetry or something like that, with line Y equals X. Cool. One more. Any questions about example 3? Let's do example 4. You want to call someone about this, so make sure you're checking in with your neighbor.
Oh, wait.
You ready? In about 15 seconds. Joseph, help me out with this one, please.
Um, so first I did the parent function. So it's the one that like how like goes like that.
Perfect.
So
So what does it
when
do?
it's 0, 0, then 1, 1, then another one, 4, 2. And then the last one is 9, 3. So then since it's x minus 2, then I shift all the points to the right twice.
Okay. Coordinates are too hard to say.
Yeah. Yeah,
Right.
and then that last one didn't really fit on, but yeah,
Off the graph.
the graph.
You can still make it happen.
And I flipping the x and the y's to get 0, 2. Then I got uh, 2, 6.
Okay, 2,6. I feel like there's one before that.
Oh, sorry. Then let's see the
Because I noticed there's a point of 3, 1,
great.
1, 3. And I think that's enough, isn't it?
Yeah, because the other one that gets it off.
Yeah, it's fine there. Okay, are we good?
I forgot to do stuff, but y equals.
And I'm also gonna do something I haven't done on the other ones, just to be clear about what's going on here. This graph is just y equals f of x. And this one is y equals f inverse of x, just to label exactly what's going on. Okay, and Joseph, do you want to continue doing this algebraically or? Okay. What should I write?
The y equals the square root of x minus 2.
Okay.
Then I swap the y's and again. So then I got x equals the square root of y minus 2.
Yes.
Then I squared both sides. Yeah. X squared equals y minus 2, and then I move the 2 over to the other side to get x squared plus 2 equals y.
Yes.
And that's x squared plus 2 equals f inverse.
I'll go ahead and reverse the sides if you don't mind. Anything else? Nicely done. Thank you. Are we good with this? Any questions? There's just one last thing. There's one thing we have to adjust here. X squared looks like this, doesn't it? It's a parabola. Is that what our inverse function looks like? No, we don't have the entire parabola. So how do I keep it just to that right side?
As
Greater than-
be greater than or equal to.
Yeah, so here I'm gonna say if x is greater than or equal to 0. Just to establish that we only have that one side of it. So there's a little bit of a trick there. Something to watch out for. And we can see that on the graph, but it doesn't come out algebraically. So
Scroll. Oh, the other one for the math.
sure. Like that?
Yeah.
So that's it for the unit. Crazy unit, huh? Quick, short and sweet.
Range is bottom.
That's time to work on your assignment. I do recommend also maybe starting on the review.
We're gonna, all of the next classes review, right?
Correct.
Next class is 5.